Hi, hello, good evening. Welcome back to my channel. So today I'm going to start with the 16th module of light chapter. So in our previous module we have discussed about what is refraction and what causes refraction. So in this module we are going to learn more about refraction. Are you ready? So get ready with your pen, book and note down the important points. So today we will begin with important laws. So write the heading. It is laws of refraction. Laws of refraction. And let's have a quick recap of what is refraction. So what is refraction? Very good. It is bending of light when it enters a different medium obliquely or a medium with different optical density. And what causes refraction? It is due to the change in speed of light, or we can say due to the change in the optical density. That's great. So let's see some important laws. So I'm just drawing the diagram again. It's the interface separating two media. So I have medium 1 and medium 2, and this is the normal, and incident ray hits the normal line. Okay, this is the incident ray, point of incidence. So we draw the normal at the point of incidence. Suppose if this is the rarer medium and this is the denser medium. So in our previous module we have learned what happens to the ray of light when it enters the denser medium. So what do you think will happen? Exactly, speed of light decreases. So what happens to the path of light ray if speed decreases? Very good, it bends towards the normal. So it bends towards the normal. Yes. So our first law states that the incident ray, the refracted ray and the normal at the point of incidence. So we usually draw the normal where the light ray hits. So that is the meaning of at the point of incidence. All lie on the same plane. So in the diagram you can see incident ray, normal, refracted ray, they all lie on the same plane. This is the first law. Now let's see second law. Second law is a bit tricky. So listen carefully. And we also learned the angle between incident ray and the normal. What is it called? Very good. Angle of incidence. And what about the angle between refracted ray and the normal? Angle of refraction. Yes, now let's understand what is the second law. So here I'm going to introduce a new term, that is sin I and sin R. So don't get confused. So here sin is a trigonometric function. So you will learn more about trigonometric functions in mathematics. So in physics we are using only the sin I and sin R. So sin I means, so let us understand what it is. Okay, so we have the angle of incidence here, angle of refraction here. Now let's see what is sin I. So the trigonometric functions usually apply to a right angle triangle. So I'm going to construct a right angle triangle here. Okay, so you have a right angle triangle here. This is the normal line. So this will be the 90 degree and this is the hypotenuse. This is your angle of incidence. So sin theta or sin I, theta means angle, so instead of theta I am taking the angle of incidence because we have I and R. So sin I is usually opposite side by hypotenuse. So trigonometric function sin means it is opposite side of a right angle triangle divided by hypotenuse. So if I take sin I, this is the opposite side and this is the hypotenuse. So depending on the angle of incidence, so if you have a larger angle of incidence, the side again changes. Similarly for sine r, according to angle of incidence, angle of refraction will also change. So the fraction that we take for sine r will also change. So we are using, so you don't have to have a deep understanding of what is sine I and sine r. You will learn more about this in your mathematics. So here you just have to remember two functions, sine of angle of incidence and sine of angle of refraction. That is enough. So let's understand what is the second law. The second law is also called Snell's law. Snell's law of refraction. Okay, it is named after the scientist Snell. So he's the person who introduced or who studied about the behavior of light using trigonometric functions sine I and sine r. So the law states that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given color of light and pair of media. Okay, so two important statements that you have remember here is given color of light and pair of media. These are the two terms that is very important when we are stating this law. Okay, so why do we use a given color and pair of media in this case? Let's understand that. Okay, yes. So let's express this statement mathematically. So ratio of sine of angle of incidence to sine of angle of refraction is a constant. So let's represent mathematically, that is ratio means fraction, right? So sine I divided by sine r is a constant. So I have told you sine I means it is the opposite side by hypotenuse. So you'll get a numerical value there. Here also when you find sine r, again you will get a numerical value. So if you find the ratio of those numerical value, you will get a constant. Okay, and it's a number. Say for example, if I'm finding this angle and you got some value, say for example 1.3. Okay, this is the constant that you got after simplifying this sine functions. Okay, so this constant value is a constant for a given pair of media. For example, if you are taking air and water, these are the two pair of media that you have taken for, it's a pair of media that you have taken for an experiment. Okay, so for this pair of media, this is a constant. So that constant value is 1.3. Now if you are changing it, suppose air and glass, you're changing the medium. So if you change the medium, then this constant will again change. So for a given pair, it is always a constant. That is the meaning of pair of media. So if you change the medias, then the constant value will change. Now what about given color of light? Suppose if you are using a red color for the experiment. So red color has a different wavelength, different speed. So the bending of light will also differ. Then accordingly this constant value will change. If you are using a violet or red, green, blue, each color of light has its own wavelength and its own speed. So when it enters a different medium, the speed changes, wavelength changes. So accordingly this constant value will also change. Okay, but for a given color of light and given pair of media, it is always a constant. Even if you change your angle of incidence, accordingly the angle of refraction will also change, so that the constant will always remain as a constant for given pair. So that is the important part of the statement, given color of light and pair of media. So keep these 2 points in mind when you are studying the statement. Okay, now let's learn more about the Snell's law of refraction. Yes. So I'm starting with the same formula, that is sine I by sine r is a constant. Now I'm going to give a name to this constant. Okay, so this constant is called refractive index of the medium. Wow, it's a new term. Okay, refractive index of the medium. Don't worry about the term, we will learn about it. Okay, so now I'm using the letter, let's see, sin I by sin R equal to, this refractive index is denoted by n. Okay, so that is a constant value. Now let's learn more about refractive index. Okay, so I'm going back to this diagram. So in this diagram, we can see that when light is entering from a rarer to a denser medium, it bends. So we know that if it is rarer to denser, it bends towards the normal. Denser to rarer bends away from the normal. But we don't know how much it bends. Okay, the measure of bending of light. In order to understand how much a light ray bends when it enters a different medium, we use the term called refractive index. Okay? So refractive index tells us what? Yes, it tells us how much the speed of light changes. Speed of light changes when it enters a different medium. When it enters a different medium. So for that we use this term. Okay, so we will learn more about it. And one more thing you have to remember here is, I have told you refractive index of the medium. Why did I use of the medium? Yes, let's go back. So here when light enters from rarer to denser, so bending happens when it enters in a medium, right? When it enters to a different medium. So I have told you refractive index means, so refractive index means how much the speed of light changes or how much the light bends. So light always bends when it enters a different medium. Write the subheading, refractive index. It is denoted by small letter n. Okay. Yes. Now we have two types of refractive index. Let's learn about the first one. Okay, that is absolute refractive index. Okay, so again I'm drawing the diagram, an interface separating two medium, medium 1 and medium 2. So whenever I say absolute refractive index or simply refractive index, okay, refractive index. So refractive index is also called absolute refractive index. So in absolute refractive index, light always enters from air. Okay, enters from air. What is entering? Light always enters from air. So I'm taking this medium as air because this is the entrance point of light. And the second medium can be anything, air to glass, air to water, air to diamond, or any transparent medium. But light should always enter from air. If it is absolute refractive index, entering point or entrance point of light is air. Now let's see. What is the speed of light in air or vacuum? Very good. 3 into 10 power 8 meter per second. So this is the maximum speed of light. In all other medium, the speed of light is less than this value. Okay. So when light enters from air to any other medium, it will always bends towards the normal. Why always bends towards the normal? Because the speed of light in air or vacuum is the maximum. In all other medium, it is less than this value. Okay? Yes. Now, speed of light in air or vacuum is denoted by C, and speed of light in medium, this can be any medium, is taken as V. What is the refractive index of the medium? So, here I am finding the refractive index of this medium. Why? Because light is bending in this medium. When I say refractive index, just remember how much the light bends. Okay, so it bends in the second medium here. So refractive index of medium 2 is defined as the ratio of speed of light, that is C, speed of light in air or vacuum, to the speed of light in a medium, that is V. So this is absolute refractive index. Okay, it is the ratio of speed of light in air or vacuum to the speed of light in a medium, that is C by V. Now, C is speed of light in air or vacuum, that we already know. It is 3 into 10 power 8 meter per second. It is a constant value. So, C is a constant value. Okay, what about V? That means V means speed of light in a medium. It always changes. Okay, it will be always less than this value. So, since this part of the formula is constant, we can write N is proportional to 1 by V. Okay, if one quantity in a formula is constant, we can use this proportionality symbol. So here C is constant, so I can write N proportional to 1 by V. What does that mean? Inversely proportional. Okay, inversely proportional. So refractive index of the medium is inversely proportional to the speed of light. So what is your understanding about inversely proportional? If speed of light in a medium is more, what does it mean? Refractive index is less. When I say refractive index less, what does that mean? Very good. Bending of light is less. Just remember in that way. Okay, that is easy for you to remember. Refractive index means, yeah, how much the light bends. Okay, so if the speed of light is more, which means bending of light is less. If speed of light is less in a medium, which means bending of light is more. That is the meaning of inversely proportional. So refractive index of a medium is always inversely proportional to speed of light. Okay? Yes. Now, so we have N equal to C by V. So we know that speed of light is 3 into 10 power 8 meter per second in air or vacuum. Suppose if I am taking the speed of light in a medium, say for example 2 into 10 power 8 meter per second, which is less than the speed of light in air. Now I am finding the refractive index. So that is 3 into 10 power 8 divided by 2 into 10 power 8. So you can cancel out 10 power 8, 10 power 8. So you will get 3 by 2, that is 1.5. So refractive index of the medium is 1.5. What does it mean? I hope you thought about it. Now let's see what is the meaning of refractive index 1.5. Okay, so when I say refractive index of the medium is 1.5, it means that speed of light in that medium decreases by a factor 1.5. Another example, the refractive index of diamond is 2.42. What does this mean? Yes, the speed of light in diamond is decreased by a factor of 2.42. Okay, when light enters diamond, its speed decreases by 2.42. That is the meaning of refractive index. So this is the definition of a refractive index. Okay, so remember this definition. This is very, very important. This is the scientific definition. But if somebody asks you what is refractive index, so just you can say it just tells us how much the speed of light changes, okay, or how much the light bends when it enters a medium. That's a simple way of explaining what is refractive index. Okay, now let's understand the second type of refractive index, that is relative refractive index. Relative refractive index. So in absolute refractive index, I have told you light always enters from air or vacuum to any other medium, right? Yes. In relative refractive index, light can enter from any medium, okay, other than air. Say for example, water to glass, or glass to water, water to diamond, or water to oil, anything. Okay, but light should not enter from air. If the light is entering from air to any other medium, it becomes absolute refractive index. If it is entering from any medium to some other medium, then it becomes relative refractive index. So let's understand it better. Let's see what exactly the relative refractive index. Okay, so I'm going to draw the diagram again. Interface. This is the normal. So I'm just taking general medium like medium 1 and medium 2. Okay, medium 1, medium 2. And let's assume that this is a denser medium and this is a rarer medium. Okay, so what happens when light enters from denser to rarer? Okay, it is entering from a denser medium, then going to a rarer medium, it will bend away from the normal. So we all know that. Now in which medium bending happens? Bending occurs in the second medium, right? Yes. So I can write, since bending occurs in the second medium, I write relative refractive index as N2,1. Okay, don't get confused. Since bending occurs in the second medium, I wrote 2 first. Okay, so this bending depends on the light entering from first medium. That is why I wrote 1. Okay, N2,1, bending of light in medium 2 with respect to medium 1. That is the meaning of N2,1. Okay, refractive index of medium 2 with respect to medium 1. Yes. Now let's say the speed of light in medium 1 is V1 and speed of light in medium 2 is V2. Okay. Yes. Now let's see the formula connecting all these things. So I'm writing N2,1, so which can be written as N2 divided by N1, refractive index of 2 with respect to 1, which is equal to, so I'm going to write in terms of speed. So listen carefully. It will be V1 by V2. So why I'm writing V1 by V2? Yes, in absolute refractive index, we have seen that n is inversely proportional to v. Refractive index is inversely proportional to speed of light. So this shows inverse relation. N2 here, V2 here. N1 here, V1 here. This shows an inverse relation. Okay. This is one way of explaining what is relative refractive index. Now let's assume that light is entering from 2 to 1. Okay, in the first case it was entering from 1 to 2. Okay, so 1 to 2. Now in the second case light is entering from 2 to 1. So what happens? In which medium bending occurs? Yes, in medium 1. Bending occurs in medium 1, but this bending depends on the light entering from medium 2. So how can you write? Refractive index of 1 with respect to 2. Why did I write 1, 2? Because light is entering from 2 to 1 and bending of light occurs in 1. So bending of light in medium 1 with respect to medium 2. That is N12. So you can write N1 divided by N2, which is equal to V2 by V1. Very good. Okay. So in order to write this relation, you just have to remember from which medium to which medium the light is entering. So if light is entering from medium 1 to medium 2, we write N21 because bending occurs in medium 2. So if light is entering from 2 to 1, then bending occurs in medium 1. So we write N12. Now let's see the definition. So we can define it in two different ways. Suppose if I am writing the definition of N21, then the relative refractive index, the relative refractive index of medium 2 with respect to medium 1 can be defined as the ratio of speed of light. So the ratio of speed of light in medium 1 to medium 2. Okay, that is N21, which is equal to N2 by N1 equal to V1 by V2. Ratio of speed of light in medium 1 to speed of light in medium 2. So in the similar way, you can define N12 also. N12 is N1 by N2, which is equal to V2 by V1. So how can you define N12? Just pause the video and write the statement by yourself. So let's see the statement. The relative refractive index of medium 1 with respect to medium 2 is defined as the ratio of speed of light in medium 2 to the speed of light in medium 1. Okay, this is very important statement. So let's understand what is relative refractive index and study the statements. Don't by heart the statement. Understand what exactly is relative refractive index. Then frame the statement in your own words with proper scientific terms. Yes, so today we have learned about what is refractive index and what is absolute and relative refractive index. Okay, so absolute is n equal to c by v, relative is n21 which is equal to n2 by n1, v1 by v2, or n12 is equal to n1 by n2 which is equal to v2 by v. Also we have learned one more formula for refractive index in terms of angles, that is sin I by sin R equal to refractive index of the medium. And one important point which is related to absolute refractive index is, so we have n equal to c by v. One more point you should remember here is absolute refractive index is always greater than 1. Okay, why it is greater than 1? Because c is greater than v. Your numerator is c, that is 3 into 10 power 8, that is the maximum speed, and your denominator is always less than your numerator. Okay, so your ratio will be always greater than 1. So this point also you should remember. That is the important point you should remember. So in the next class, we are going to solve numerical problems related to refractive index. But before coming to the next class, I want you to learn these concepts thoroughly and post your doubts in the comment box. Till then, bye.